Hello and welcome to a special edition of Access, Rutland County's community news magazine. Brought to you by your local healthcare provider, the Rutland Regional Medical Center. I'm your host, Amanda Wheeler. Today our show is dedicated to the topic of severe weather. Today we'll visit a local climatologist to get his take on the wild weather and also venture up to Burlington to sit down with a warning coordination meteorologist from the National Weather Service to see if either can explain why Rutland County is in the red zone for strong storms and what we may see in the future. So Alan, we came out here today to sort of get a sense from you, being a climatologist, what is happening around this area? Why are we having these changing weather patterns that are causing severe storms? And, we've seen a huge increase in just the extreme weather snaps. We go from having a lot of snow to then extreme cold, or then we're seeing rain. And now this summer, obviously, we've gotten these storms that are producing hail and strong thunderstorms. Can you sort of explain to us a little bit about maybe what's happening so that we can better understand sort of the weather changing around here?
Well, I can. It's not easy though, because it's not just the weather here in Vermont that's changing, it's part of a whole pattern in the Northern Hemisphere. It's part of a global pattern. Mm-hmm. So the global weather is changing, and within that we are seeing more extremes here. So where do you want me to begin?
Well, you and I were just discussing maybe this big shift in sort of the jet streams. Can you sort of talk about why that makes a big impact?
There are two things that affect how strong our weather is. One is what happens locally, which is how much evaporation there is from the surface that drives strong storms, and the stronger storms have larger hail, or we didn't used to get any large hail at all, and they have stronger winds associated with them. But something like flooding depends on not just how heavy the rain is, but how long it rains. And what's happening there is that the global wave patterns that we call the jet stream that go around the whole of the Northern Hemisphere have been getting larger in amplitude, as the waves have been getting bigger from north to south, and when they do that they slow down, and if they don't move past us as fast, then we get more rain for longer, like it goes on raining, and we get a whole series of storms for maybe a whole day.
So the longer this jet stream sort of stays where it's at, the longer these periods of weather are going to stay.
Right. So we've been having a relatively wet summer this year, with the waves and the rain being in a branch of the jet stream, a very strong branch across the eastern United States. But at the same time, California, which is in another part of the wave, is now in the severest drought that it's had in a century. So it's part and parcel of the same thing, and other parts of the Northern Hemisphere are in other extremes under the same kind of wave pattern.
And so there's obviously a lot of theories out there as to what's causing, the shift in these patterns. Can you sort of explain maybe theories that we think are contributing to this?
Well, I'll start at the base. The climate system is changing. The first driver is the fact that we have a fossil fuel economy. We're burning a lot of fossil fuels. The carbon dioxide goes up into the atmosphere, and it's a heat trapping gas, and we call it a greenhouse gas, and it stops the Earth cooling to space. And that just sets in motion a whole train of things. Mm-hmm. The first one is it warms the Earth and increases evaporation from the oceans. And water vapor is a much stronger greenhouse gas than carbon dioxide, so that triples the effect that comes from the burning of the fossil fuels. And it also puts more water into the atmosphere, and the water is the source of all the energy for thunderstorms, squall lines, hurricanes, all those things. The typhoons in the Pacific that have been very severe, all those are driven because there's more water in the atmosphere.
Now, these severe thunderstorms we're getting, is it because there's sort of, you've got the polar vortex everyone keeps talking about that's sort of dipping down over Lake Michigan and causing, it to be 20 degrees cooler there than they're typically experiencing this time of year? Is that combining with, all the moisture sort of from the East Coast that's causing this? Or what's sort of happening that's causing, the reds and the oranges that we're seeing on the radar that's freaking everyone out?
Well, no point in getting freaked out. It's what we're going to have to live with. But what happens if you have a large wave in the jet stream and cold air comes down in the middle from Canada, and it's warm along the oceans and along the Gulf Stream, is that this gradient of temperature between the cool and the ocean gets stronger. Mm-hmm. And that gradient of temperature amplifies the intensity of the storms along that front between the cold and the warm. And that happened a lot this winter. This past winter was very cold in the Midwest, and the Gulf Stream is still pretty much its normal temperature. So we had a whole series of very strong, mostly snowstorms, develop up the East Coast.
So basically the pattern we're seeing now with these severe storms is very similar to what we saw this winter, just in a different form.
Just warmer.
Right, there we saw this heavy snow, some ice storms.
Right.
So it's a similar thing, it's just the different time of year.
That's right. And this kind of stationary pattern is similar. And even, California had terrible drought all through the last winter period. And if you follow that chain downstream, the storms that developed over the eastern United States, they gave us a lot of snow. They intensified even more across the Atlantic, and Britain was flooded. It had every week practically a very strong cyclone system that flooded much of England for much of the winter.
Do you think that here in Vermont, and specifically in Rutland County, we're going to be seeing more of a flooding pattern and more intense rain? I mean, what should people this isn't just a fluke, this is going to stick around for a little while, correct?
Well, we've been seeing it intensify for about 10 years now. And if you go back to, say, 2011, which was a year of 2 big floods in Vermont, the flood on Lake Champlain in the spring, which was partly caused by melting of snow with heavy rain and warm rain in April and May, but it lasted a long time. The level of Lake Champlain came up to 103 feet, and it was above flood stage, I think, for 2 months. And then it stayed wet through the summer, and then when Irene came along in the fall, the ground was already wet, and we got 6-8 inches of rain out of a tropical storm Irene, and because the ground was wet, it ran off and we got catastrophic flooding. So if you look at that 6-month period across the United States, you see there was a pattern in place. From Ohio to Vermont had the wettest 6-month period on record, whereas down in the south, Texas and New Mexico was the driest on record drought for them. So this pattern, for us, we were woken up by 2011, and particularly the Irene flood has set in motion a lot of planning purposes, thinking about how we can move out of the floodplains, how we can think about storing more water on the landscape so less runs off our hills. So for us it's become the model of, yes, what we're going to have to plan for in the future. But when I'm down in Texas giving a talk, for them it's the model of the most severe drought that they're going to have to deal with, and they're using it also for planning in the future, exactly the same summer, different parts of the US.
And so today, actually, the state announced that they just sort of started this online flood get you prepared sort of website,
Right.
to sort of let people know these are sort of the things you need to keep in mind. These are how you prepare for these big storms.
Right.
Typically folks around here, they hear microbursts, they don't know what it means. They see potential threat of tornado and think, how can we have tornadoes here? But there's a chance that this could actually happen.
Right. Well, in a way, that tornado warning that came out, I think it was at the end of May, was fortuitous, because when they said take cover now, people did. And what we got instead of a tornado was golf ball size hail, which is very dangerous to be outside in that. The microburst that you referred to, well, meteorologists coin jargon, and that jargon comes back from 20 or maybe 30 years ago now. We were losing aircraft on landing in thunderstorms, so they went out and studied it, and what they found was that there are sometimes very strong downdrafts, we call them, bursts coming down out of clouds that are quite small, only a kilometer or 2 across, and they're driven down and accelerated by 2 things. One is the evaporation of rain, which cools the air and makes it cold, and the other is just the weight of a lot of rain and maybe hail makes the air very cold and the jargon is negatively buoyant. We know, hot air goes up, well, cold, dense air with lots of rain in it goes down very fast. Comes down in a burst and then spreads out. And you can get 50, 60 mile an hour winds in all directions from one of those bursts coming down. And we've had a few of those in Vermont that have blown over a lot of trees.
The one in Poultney, I talked to the Weather Service, they said from everything they've seen, the eyewitness description, it seems like it was a microburst that hit there in that last storm on July 3rd, and winds up to 80 miles an hour. I mean, folks around here, that you hear that number and you think, how is that possible?
Well, these are the kind of severe storms that are common out in Oklahoma, common out there with large hail. But what's happening is these more severe ones are moving west. Someone told me who had relatives in Ohio that they had baseball-size hail. Ohio never had baseball-size hail. That were real extremes out west. We, I don't think, have had golf ball-size hail. Well, I don't know when we last had any in Vermont. So yes, the severity is increasing, and the severity is because the intensity of a storm depends really on how much water is feeding it below cloud base. The water vapor evaporates from the surface, and now if you look out across the landscape, or when I was up here this morning, there are clouds everywhere in the forests. That means everything is saturated with water,
Right.
and it's much more humid. This is not dry, warm weather, and that water that's in the atmosphere goes up and it condenses when it goes through cloud space.
Okay.
It takes a lot of energy to evaporate water, and you get it all back when the water vapor condenses.
So this morning we woke up, it looked almost foggy because there was all this. So anytime you're seeing that, it means there's extra water in the air, and that's what's sort of fueling.
It's fueling more storms. You need more than that. You have to have what was here yesterday was a band of storms all the way up the east coast, and that's just slowly moved off the coast, and behind it, it's trying to clear out. But because it's so wet, there's lots of clouds in the sky. But there's not really enough intense sunshine today. You need two things. You need the water, and you need the sunshine to heat up the ground. When you have those, we can get storms after storms, day after day.
So going forward, as people sort of hear this and hear that, it's a changing weather pattern. Typically when you're hearing the weather on a day-to-day basis, they're only looking ahead to the week.
Right.
When we're talking about this in general, what should people know going forward? That this weather pattern's here to stay for a while? Or what are the few sort of things you would like the public to know?
Well, of course, everyone would like to be able to predict the weather next month, next winter, next year, and that we can't do. We can only, as you say, predict for about, with any kind of detail, 7, maybe 10 days ahead. But the pattern of what we've been seeing, this slowing down of the jet streams, the more stationary weather giving us longer periods of rain, and in some parts of the country longer periods of drought, we expect that to continue. We don't fully understand all the details. People have been studying them now for several years, and there are several theories about that. But we should expect that. So in terms of planning, if you're in the think about water more. Think about water more. Where does it go? If you do reconstruction, or you put in culverts, or you're building something, try and allow more to be stored on the landscape, either in ponds or go into the ground, and always start oversizing your culverts. I have one just over here that I changed just 2 years before Irene, and the contractor said, 12-inch culvert, big enough for here, let's put in another one. And I said, no, let's put in another size larger. And I was right, because during Irene, that culvert came within about 2 inches of being totally full and therefore getting washed away. So I made a good judgment, but that's the kind of thing people need to do who are involved in planning in our townships or in road maintenance. They need to start thinking in terms of more water.
So because we think this is around for a while, the departments around here that are dealing with water, doing new lines, they have to build the culverts, or folks that are in the process of constructing, building a new place, they need to keep these things in mind.
Keep these things in mind. Our difficulty we have is that our engineering standards and for culverts and everything are all out of date. They were all based on what happened 50 to 100 years ago, and we're now in a changing situation where the intensity of storms and the amount of daily maximum rainfall is going up, and we don't have standards for the future. And yet when we build things, we have to plan ahead for decades. And we're making progress. I mean, most of the new bridges survived Tropical Storm Irene in Vermont, but I think we lost 1,000 culverts of a smaller size that were already outdated. So that's on the construction side. For people, the farmers, the people who are growing crops here, all of them are used to dealing with the weather, and they are, of course, adapting and planning and trying to get their hay in when it's dry, just as always.
Yeah, is there anything actually on the agricultural side for, farmers, gardeners, folks who, tend their fields? Is there anything for them to keep in mind with this as we sort of see this all change?
Well, the problem is it's been extremes. If you turn your mind back to 2012, we had a very warm winter with very little snow. When we have little snow on the ground, it stays warmer because snow reflects sunlight and keeps it cold. But that was because we had a stationary pattern there, and across almost the entire eastern United States, record temperatures over that winter, all the way up into Canada, where it was very, very warm. What we had that was 2012, January, February, March. What we had 2014, January, February, March was almost the mirror opposite. And that makes it difficult. In the long time span of 10, 20 years, our winters have been getting warmer, and that's helped many, many crops and many, many shrubs winter over, and many pests as well. I mean, the march north of ticks and Lyme disease is going with a general progression of warmer winters. But within that, we're now getting extremes, and that makes the planning on an agricultural side more difficult.
So if you're going to predict ski season for, Killington, Pico, what they can expect, is it going to be more snow, or can you not forecast that?
I'm not going to forecast that. I had a discussion 20 years ago with the Ski Association of America, and I was asked to make this case then, and against a rather skeptical climatologist. And the critical question I put to him is, he was saying things aren't going to change much, and things have changed a lot in those 20 years. And I asked him, well, would you advise them to listen to your advice or buy more snowmaking equipment? And of course he was honest enough to say buy more snowmaking equipment. And that improved technology there has, whenever if it gets cold enough, we can make snow. If we get natural snow like we did last winter, it's very good because the whole climate of Vermont then stays much, much colder. As much as 10 degrees colder if we have snow cover. But I can't predict next winter.
Yep.
I don't know which one it's going to be. And
is there potential for the jet stream we see now to totally be different by then?
Because we don't fully understand what's happening, and perhaps more deeply because the Earth's climate system is actually a very unstable system. You have to think of it, these jet stream waves are unstable waves that are moving heat from the tropics where it's warm to the poles where it's very cold. They're not uniform, they change, they amplify, and they're not basically stable. And that means that we get a lot of patterns there and changes in pattern. Within that, what we are seeing, if you talk to the forecasters in Burlington and ask them what they have seen in the last 5 or 10 years, they will say they've seen many types of weather that they had not seen in the previous 30. But that doesn't make the forecasting any easier when you're seeing a lot of variability and a lot of extremes. So what I encourage people to do is to go out and watch and develop a deeper understanding of the natural world and the weather among that, because I think it's much more helpful than either to worry about it. Just as we have to pay attention to the weather on a day-by-day basis, we need to start paying attention to these larger scale patterns on the Earth on a week-by-week and a month-by-month and a season-by-season basis, so that we build up a sense of what our climate now looks like rather than what it looked like when we were children.
Right.
Because it has changed.
And this whole climate change, you've got people one way saying, no way it exists. Our climate is changing.
Well, the climate is changing.
Right.
The people who are trying to deny that it's changing are part of a group that is motivated by either financial reasons or by political reasons. But you can't deny the change that's happening to the climate, or that sea level is coming up and we're facing large sea level rise later this century and next century. It's going to happen.
Yeah.
And we have to respond and adapt to it. And we have to ask the more fundamental question, which we haven't addressed at all, which is, if we stay on a fossil fuel economy, then by the end of the century, our climate will be almost unrecognizable in ways, many of which we can't predict, but most of them will be very, we won't like what we see.
So being a climatologist from this area, is it reassuring to you to see sort of the forward thinking of our area in the investment in all the solar panels and trying to make Rutland the solar capital of the Northeast?
Well, I'm very supportive of that, and I'm doing some analysis with Rutland High School on solar Rutland, because we have all this solar data and we can understand how it works with the climate system. But of course, Vermont is only part of a US and part of a global system. And what we have to do is not only go through the transition here in Vermont to a much more efficient society that's not dependent on fossil fuels, and the faster we do that, the better off we will be. We've also got to encourage the rest of the country. We've got to encourage the US to change. This is a whole other topic, of course, but the essence of the issue here is that we have always been free to dump all our waste streams into the atmosphere, the rivers, the lakes and the oceans for free. As long as we can do that, we will burn fossil fuels and we'll dump the CO2 in the atmosphere. We have to start putting some sort of charge, some sort of cost that will help the economic system recognize that the damage that we are doing downstream from burning fossil fuels are huge, absolutely huge. They are costs that we can never pay. And a relatively small increase in the cost of our fossil fuel now will save 50 times. A billion spent now will save 50 billion down in our children and grandchildren's time. It's an absolutely huge return on a small investment in the kind of transition you're seeing here in Vermont, yes. I said England had tremendous flooding downstream of our coastal storms here last winter. So in around March, the British Met Office summoned an emergency meeting of all its scientists to try and explain to the British public what was happening. And they did some very interesting work, and they tracked some of things back to the United States, across the United States. They noticed the droughts in California, but they tracked some of it to waves that started way in the Western Pacific, where it was extremely warm. And you may remember there had been a very strong typhoon called Haiyan that had devastated the Philippines. And all that chain of things was all connected back to the extreme flooding they had in England. So it's global. It's not something we're just experiencing here. It's part of a global pattern. It's part of something we need to understand. We need to accept that we're partly responsible for the transition, and we need to start asking very seriously what we are willing to do to make the transformation to an efficient society not dependent on fossil fuels, because we can roughly halve. We're going to see more change this century, but we can roughly halve the change in climate that we're going to see by the end of the century if we start seriously to make that transition.
Great. Thank you so much for joining us and sort of helping us sort of understand what's happening around here and our future as we go forward.
I'm delighted to be of any help.
Thank you. After our visit with the climatologist, we traveled to Burlington to sit down with a meteorologist from the National Weather Service to get his take.
Really, what's happened this summer is not too much different than we've had in previous summers. It's just that some summers you may not see any strong to severe thunderstorms, and other summers you may be, the magnet to get all these storms. And right now it looks just the way the boundary is set up. Rutland, Windsor County southward has been the jackpot for severe storms this summer.
Poultney was hit hard during the July 3rd storm that swept through. On the ground, damage is still visible. The National Weather Service says by its accounts, it was a microburst that caused the destruction.
A microburst, all that really is there's in any thunderstorm, there are generally winds blowing at anywhere between 8 and 15,000 feet. And there's some sort of momentum with those winds. A microburst, all it is you've had a buildup. Thunderstorms are made up of updrafts and downdrafts. Generally, when the thunderstorm gets to its mature stage, you got a lot more updraft than downdraft, but at least you got some sort of a downdraft. What happens with a microburst is you've got this updraft, and it's actually holding back the rain. It's actually holding back the rain and the hail and some of those winds that would normally translate down to a point where it's so heavy, it's so forceful in that storm, it just suddenly drops. It's kind of like a pail of water. If you took a pail of water and you dumped it on the driveway, you get that sloshing effect or whatever. Well, take that pail of water and walk forward. And that the fanning of that water is the fanning of the wind in a microburst. It just comes down and it fans in the direction of where the storm is traveling. Poultney saw that just recently, where they had winds of maybe 80 miles an hour plus in a microburst across the state.
When determining if a microburst or tornado caused destruction, several factors are taken into consideration before ever venturing to the scene.
Well, first of all, when we have those storms move through and we need to see, we first want to know several things before we go out in the field and do a storm survey. Was the meteorological conditions, was the atmosphere conducive to a turning of the wind? Because a tornado requires a wind coming in from, say, the south or southeast at the surface, and then maybe southwest at about 5,000 feet, and then more of a west or northwesterly at 10, 15,000. If you get all those, then you've got the chance of some sort of a turning of a storm. There's still about 80 different mechanics that are needed to get that turning in the mid-levels all the way down to the ground. But we first need to see, is that even possible? If it's possible, then we go and look at the radar as well and see, is there any indications in the radar showing a couplet of winds moving in a circular direction? If we see that, 90% of the time when we see those, they're not even reaching the ground. And then if we see those combinations of the two, we go out and do this damage survey. And at that point, we need to see, is the pattern more of a tight circular pattern or is it more of a fan out pattern? And certainly with the Pulteney stuff, it was more of a fanning out pattern, plus all the other characteristics I mentioned, all the radar checks and the atmosphere were not conducive for tornadoes, because the storm that ended up affecting Pulteney affected different places in New York, and all their investigations came to the same conclusions as ours, which everything was microburst.
By all accounts, the weather pattern we're in will be around for a while, and we all need to be prepared for severe storms.
Overall, Rutland and Windsor and further points to the south, especially you get into Western Mass and the Capital District in New York, are a little bit more vulnerable than in the northern Vermont, and that's because of a typical summer. There tends to be that boundary where it's a little bit more hot and humid, a little more unstable in that southern southwest portion of the state versus the northern. So usually thunderstorms like to interact where there are boundaries. And since there is somewhat of a small climatological microclimate effect down there in southern Vermont, there are tendencies to get more storms than here, say, in Burlington.
Moving forward, Whittier agrees with the climatologist. Our infrastructure needs to be improved to sustain a new normal.
Infrastructure has been built anywhere from the late 1800s to early 1900s. So already they were dealing with infrastructure for a population of the late 1800s and early 1900s and not here in the 21st century. So you have already probably tenfolded some of these locations' population. You've got much more asphalt on the roads and stuff that you ever had because it was just dirt roads. So all this water, when it falls, has to go somewhere, and because you don't have the grass to absorb it, you got streets and asphalt, they become rivers, and then they get thrown into your culverts and they get thrown into your infrastructure and they can't hold it. You add that to, because of slight global warming in the past couple of years, that when the atmosphere is warmer, its ability to hold moisture is greater, that you're going to get more frequencies of these heavy rainfall rate events, intensity events, and obviously you're going to cause problems. Rutland, with just the way their infrastructure is, as well as a brook that runs near there through the city, has been prone that you get an inch of rain in an hour or less than an hour, and you've got urbanized flash flooding right through the center of Rutland.
While we hope the worst storms are over for the summer, the National Weather Service says to stay on alert.
The season for severe weather here in Vermont is generally can start as early as late April and can maybe be as late as early October. But the heart of this severe weather season is generally June through August. So we still have plenty of months left. Just keep an eye to the sky, listen to the radio for any forecasts, and if you're planning on an outdoor venture, just make sure you time it perfectly, and at the first signs of any darkening clouds, the best bet is to just get inside.
There are several ways you can stay connected to the weather right here in Rutland. The first, head to pegtv.com or visit our website on your smartphone or tablet. On our homepage, we have a hyper-local radar that stays up to the minute, showing what's going on right here. To assess your community's risk or learn ways to make your own plan in case of a flood or other extreme weather, visit the state's new website, Flood Ready Vermont. The website is floodready.vermont.gov. That's going to do it for us today and this special edition of Access. If you have a story idea or an upcoming event you'd like us to highlight, send an email to awheeler@pegtv.com or call 747-0151. Until next time, for Access, I'm Amanda Wheeler. Take care.